All right, so if you look on the flow chart, yours does not look like this yet. You got a quadrilateral. That's okay. Quadrilateral is a polygon with 4 sides, and there are different categories, just like you have different categories of animals. What are some categories of animals?
Birds.
Oh, I meant like birds, mammals.
That's what I said. Shark.
Reptile.
Amphibian.
Fishes.
My dad.
I think we already said fish. But you get it. So there are different categories. There's a non-category. There's a parallelogram category, which is most of this chapter. Trapezoids and kites. So again, you're just going to learn the definitions of those. We'll see a trapezoid again in chapter 11. So this will now look like your chart. You're going to write in. You have parallelograms. That is a quadrilateral with 2 pairs of parallel sides.
Can we write this?
Yep, you're like, write it. And then you will also write the properties of a parallelogram. There are 4 of them. This is not new information, just written in a different format. You have opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. It's written in a new format so that you can study. You can study for math. You can especially study for geometry. If you don't know what equals what, then you don't know how to do anything. So you see you have 2 arrows. You got a rectangle and a rhombus. We dealt with a rhombus yesterday, and there were 2 properties of a rhombus. All sides are congruent. The diagonals intersect and form 90. And the diagonals bisect angles. Going to go to our notes, 7.4, page 3. We'll go back to a rhombus to review these. We'll learn about a rectangle and a square, and then we're finished with 7.4. All right, so if you look, we have the properties at the bottom of the screen. So if you did not finish writing down the rhombus properties, they're down here. We're going to find the measure of each of these. So we got BC. Is this a side or a diagonal?
It is a side.
It's a side. What do I know about the sides of a rhombus? All sides are congruent. It says that in our properties. So then what's the measure of BC? 9. Because AB is 9, all of them are going to be 9. Then we'd like to look for AC. Is this a side or a diagonal? It's a diagonal. What other part of the diagonal have I been given? 7. If I look at my properties of a rhombus, my diagonals are perpendicular. That deals with some angles. That doesn't help me. My diagonals bisect angles. That also doesn't help me right now. So I need to go back to my parallelogram properties. Diagonals bisect each other. So if AC is 7, what is EC? 7, so the whole line is 14. All right, and then I want you to put a star next to this one. There is a problem like this in your classwork today, and students struggle, and I refer them back to this one, okay? So we're looking for ADC. That is this angle. I would write that. All right. What is the only angle we're given? The C. Well, are we given all of C? We're just given half of it. I know that we're given half because what do the diagonals do?
Not really half.
Yeah, exactly half. Diagonals bisect angles. That means they cut an angle in half. So if the right portion of C is 44, what is the left portion? 44. So what is the whole angle of angle C? 88. What relationship would I call angle D and angle C? They're consecutive. What do I know about consecutive angles? They're supplementary. Perfect. So then that means they add up to what number? 180. So 180 minus 88. Ooh, that's terrible. 180 minus 88 is 92 degrees. So if you're struggling later and I refer you, it's going to be to this problem. Questions on this? Okay. We move on to our rhombus property. There is only rhombus. Our rectangle property. There is only one. There is only one property. Please don't write anything down until I told you what it is. A parallelogram is a rectangle if and only if its diagonals are congruent. So if you look, you should not be writing anything yet. The only thing you want to write is that diagonals are congruent. So whatever the measure of one diagonal in a rectangle is, that's the measure of the other diagonal in the rectangle. Right there. Right under where it says rectangle property. The big blank, that's fine. You're supposed to write it in the blank, but it's fine.
Wow.
It's fine.
You just put a blank.
All right, so what if I said BD was 8? What would the measure of this piece of a line be?
4.
It'd be 4. Because the whole line would be 8, because they're congruent, 8 and 8. Half of that would be 4. Okay, so keep that in mind. So we are going to, and the last thing. Rectangles, all the angles equal 90. So let's use our brains for a second. If this angle was 70, could the other portion of the angle also be 70?
No.
No. What would it be?
29. Or 30. Oh, I was looking at the other one. 30.
20, because they have to add up to 90.
Oh, yeah.
You're good.
I was looking.
So also keep in mind, just look at it. If I wrote this arc, does this slice of pizza look like it's the same slice as this one? It's not. Okay, so keep that in mind while you're looking at this. It is going to be to scale. So we're looking at number 6, 7, and 8. Given that HFG is 31 and EG is 17, find the indicated measure. We're actually going to do 6 and 8 and then do number 7. We're trying to find FHG, so which is this angle. And the only angle we're given is 31 degrees. There are a couple of ways to do this. Can anybody think of one way? I get what you're saying. What are you saying?
You could just split it in half.
If this angle is 31, what other angle is 31?
That angle.
Alternate interior angles. So this angle is also 31. What do I know about the angles of a rectangle?
They added to 90.
They add up to 90. So how can I figure out what the missing piece is? Subtract 31 from 90. So 90 minus 31, which is 59. So that means FHG is 59 degrees. Here was the second way you could do this. This is a triangle. Do we agree? The purple? We agree? Sit your head up. Sit up. This was 31. What's the measure of this angle of G?
90.
It's 90. So either way, you could have added them up, set them equal to 180, or you could subtract from 90. Same thing. So number 8, we're skipping to. It says find the measure of EFH. EFH. All right, what do we think the measure of this angle will be?
90.
It will not be 90.
Wait, what?
I would listen to Jerron.
I'm listening to Jerron now.
I highlighted it in like this pinkish color. What is the measure of the entire angle? 90. What's 90 minus 31? We just found it. 59. So this angle is 59 degrees. So 6 and 8 are 59 degrees. All right, the last one, HF. So I'm going to erase for this. HF. Is this a side or a diagonal? Diagonal. What do I know about the diagonals of a rectangle? They're congruent. What it looks like is that I don't have any measurements of a diagonal. But where do I have it? In the instructions. Praise God. EG is 17. So if EG and its length is 17, what's the length of HG? 17. So we got 59, 17, and 59. We're going to go back to our flow chart. Oh, no, just kidding. Flip one more. Then we finish the flow chart. You will see a problem like this tomorrow on your quiz. So in rectangle QRST, we have QS. Yep, we do. Which is 5x minus 31. And then we have TR, which is what? 2x plus 11. What do I know about my diagonals? They're congruent. So what do I do with them? Set them equal. 5x minus 31 will equal 2x plus 11. What will I move first? The 2x. 3x minus 31 equals 11. What do I move next? 31. So 3x equals 42. So x equals 14. Did I answer the question? I did not. Find the lengths. So what do I need to do with 14? Plug it in. So I know RT equals 2 times 14 plus 11. What's 2 times 14? 28. Plus 11 is 39. You could also plug it into the other. I just plugged it into the easier one. Just for your reference, 5 times 14 is 70. Minus 31 is still 39. All right, now we go back to the flowchart. We'll finish writing it in. We got the rhombus and then the rectangle. All the angles are 90. The diagonals are congruent to each other. And then the parallelogram that gets all of the above, has all of the properties, is a square. And that leads us to our last example. So we're going to go back to our notes, do our last example. The diagonals of square LMNP intersect at K. Given that MK is 1/2, find the indicated measure. So number 9, we find PK. Is this a side or a diagonal? PK? Diagonal. All right. So what are we thinking that PK will be? 1/2. I agree. It will be 1/2 because the diagonals bisect each other at K. All right, so then we're looking for P, K, N. So what you want to notice is that this is where the two diagonals intersect. A square has the same properties as a rhombus. What happens when the diagonals intersect at a rhombus? They form 90. So that applies here as well. So it would be this property. So then the measure of PK, what is it, PKN, is going to be 90. Because in a rhombus, the diagonals are perpendicular, that's also true in a square. So they intersect and they'll form 90. So all of these angles around the center will be 90. That is true in a rhombus and a square, but not a rectangle. All right, and then the last, M and K. Then Mason can tell his joke. M and K. What is the measure of the entire angle at N? 90. So we keep that in mind. Since this is part rhombus, where the diagonals, they bisect angles. So how would you bisect 90? Divided by 2. What is 90 divided by 2? 45. So 45. There you go.